Good day, everyone. Can you all hear me? Let me see. Thank you so much for joining us today. We are very excited to be launching Shecco's World Guide to Low-Charge Ammonia. My name is Ilana Kuchenberg. I'm the Deputy Manager for Shecco's Market Development Department, and I'm joined by Zita Laumann, our Junior Market Analyst in our office in Brussels. And we're going to be giving you some insights into what to expect from the guide. First things first, make sure to check your audio settings to see if you can hear us. Please note that all participants will be muted, but hopefully you won't have any issues. We will be recording this as well. So we do encourage you to join the discussion. You'll see the Q&A little icon there. We'll be taking questions throughout and then answer them at the end. And if we can't answer any of your questions, we'll be sending them through to you in writing at the end. We will also be doing a few polls as we go along, so please participate. This will be good for everyone. Thank you. So let's look at the agenda for today. I'm going to do a quick introduction before I hand over to Zita, who's going to take you through the guide, to highlight a few key features of the research we found and what the market looks like now. And then after Zita's conclusion, then we'll get to the questions. So remember to send them in. Thank you. As I mentioned, I'm Ilana Kuchenberg. I have about 10 years of experience in the HVAC&R industry. I initially joined Shecco as part of the media team before I moved over to market development, where we now look at market research, policy analysis, and specialized campaigns, all for the adoption, the acceleration of the adoption of climate-friendly technologies. And then Zita, who's going to be explaining to you more about the guide. She's our junior market analyst, as I mentioned, and she has a background in renewable energies and environmental sciences. So you're in very good hands. Look, first things, about Shecco, for those of you who don't know us, just some bit of background about how we got to this point. Shecco is a global market accelerator for climate-friendly technologies with a focus on the HVAC&R industry on natural refrigerants. So this includes CO2, ammonia, hydrocarbons, water, and air. We have offices in Europe, Japan, America, and Australia. And all of this, as you can see, we have the media department, events, and market research. This is all built on our Shecco base of market development knowledge. You might recognize some of our brands there, the websites, Accelerate Magazine, or Atmosphere events. So yeah, that's everything we do is about natural refrigerants, really. So then to look at how everything came about for this guide, we were noticing that low-charge ammonia was emerging as a trend in the industrial refrigeration market over the past years. So it was becoming more and more popular, yet we couldn't find a lot of information available on this. So we identified a need for a global guide to help propel ammonia into the 21st century. This is part of Shecco's mission to help accelerate the uptake of such sustainable technologies. So we called in the help of some experts. We did a global survey research campaign just to see what the market's actually like currently and what the potential is for the future. So part 1 and 2 of the guide has already been published, and part 3 will go live after this webinar. And the guide in itself looks at the market analysis, technology trends. We look at case studies, policy, and kind of all the applications where you can use low-charge ammonia. Then we would just like to take a moment to actually thank our supporters and our partners. We really couldn't have done this without you. All these people here, everyone who's contributed to the guide, everyone who helped us review it, we really do appreciate it. And I think we have something we can be proud of now. Thanks. And yeah, I think the only thing that's left to do then is for me to hand you over to Zita, who's going to highlight some key features of the guide and take you through it to see what you can expect from it. So over to you, Zita.
Yeah, thank you, Ilana. So I'm going to present the main findings of the guide. And first of all, about the structure of the guide. The guide is structured into 3 parts, and each of them has 2 chapters. Part 1 and 3 have already been released, as Ilana said, and part 3 will be released shortly after this webinar. Then we are talking about part 1. So chapter 1 is really an introduction into ammonia as a refrigerant, ammonia in general, also traditional high-charge ammonia systems, its key characteristics, and its history of use. Then in chapter 2, we move on to low-charge ammonia. So we ask the question, what is low-charge ammonia? Is there a definition? How does it compare to traditional high-charge systems? And we will see that there is no definition of low-charge ammonia in the industry currently, but there are some proposed definitions by different stakeholders that we are going to present. Then coming to chapter 3, it's about the applications of low-charge ammonia, and we will see that there is a high variety of applications where ammonia has already been used, and we will present them. And then chapter 4 is about the regulations and standards related to low-charge ammonia. And then we will move on to part 3, which has been released, which will be released after the webinar, which is about low-charge ammonia today. So about the market of low-charge ammonia today. For this, we did a data collection with system manufacturers and also an industry-wide survey with more than 300 experts. And we are also going to present some case studies in this part. Then chapter 6 is about the future of low-charge ammonia and the future potential. For this, we have an interview with one of our partners. And again, I will present the main findings of our survey. So then coming to part 1, chapter 2. So as I said, chapter 1 is only about the introduction into ammonia as a refrigerant. I'm not going to present this here, but about the definition of low-charge ammonia. So currently there is no definition of low charge in no country or region, but it would be good to have one to provide clear information to all stakeholders and to know what we are talking about. There have been some industry groups in the US that have been active in proposing a definition, but there's no incorporation into standards or codes yet. And the most popular ones are the US-based International Institute of Ammonia Refrigeration, IIAR, and some other industry associations in the US who have proposed their definitions. And so the International Institute of Ammonia Refrigeration said that low charge should be between 0.5 pounds per ton of refrigeration and 7 pounds per ton of refrigeration. We will see this on the next slide. The other industry associations proposed that low charge is not more than 10 pounds per ton of refrigeration, which would be 1.3 kilogram per kilowatt. And then also shecco did a survey in 2018 where we asked respondents what they think is low charge, and it showed similarly a threshold of 10 pounds per ton of refrigeration that the respondents would like to see. Then we come to the overview. So first of all, conventional systems of ammonia have approximately, contain approximately 20 to 30 pounds per ton of refrigeration. And then low charge ammonia reduces this charge by at least 50%. So as I said, the International Institute of Ammonia Refrigeration proposed that low charge ammonia is between 0.5 pounds per ton of refrigeration and 7 pounds per ton of refrigeration. Then the other industry association said 10 pounds per ton of refrigeration. 22% of the survey respondents of our shecco survey said the same. And 41% even would like to see a definition of low charge, which is below 5 pounds per ton of refrigeration. So this is very interesting to see and for the further discussion. Then we will come to the applications of low charge ammonia. This is part 2, chapter 3. And we see that there already is a high variety of applications. So low charge ammonia is being used in the food chain, especially. And this is food and drink processing, wineries and breweries, food storage, distribution, and supermarkets. So especially low charge ammonia is very popular for cold storages. And in the guide, you will see examples, case studies of all these different applications and also of different regions. So we see that there's a high variety of applications and also regions where low charge ammonia is used. Then other applications are industry, special applications, and sports. Examples are ski slopes, ice rinks, or industrial and chemical processes. And also city and buildings that are office buildings, for example, or hospitals. Then about regulations and standards. So this is chapter 4. First of all, you all know probably the Montreal Protocol and the Kigali Amendment to the Montreal Protocol, which came into effect beginning of this year and which aims to reduce the global HFC use. The same goes for the EU F-gas regulation, which is active since 2006 and aims to reduce the quantity of F-gases used, same, and the emissions of F-gases. So these two regulations are very important for natural refrigerants, of which ammonia is one, of course, and then also for low-charge ammonia. Then we will come to the regulations and standard related to low-charge ammonia. So in Europe, beyond the F-gas regulation, there are no significant national restrictions in terms of ammonia refrigeration. But in the US, there's a different picture. So there are stricter regulations for large charges and for lower charges. Large charges meaning above 10,000 pounds, which is approximately 4,500 kilograms. And so this is really an important driver of low charge for the uptake of low charge ammonia systems in the US. Something similar goes for Japan, where a subsidy program is driving the uptake of low charge ammonia. And then in Australia, it's also the HFC phase down that we mentioned before, which is accelerating the uptake of low charge ammonia. And in China, safety standards are especially important, so that this also favors low charge ammonia. Then on the right side, we have this survey we have an infographics about this survey that we did in 2018, asking the respondents which policy measures are the most effective to drive the uptake of low charge ammonia. And so all the different answer options were ranked approximately similarly important. Bans on HFCs with high global warming potential, gradual phase down of HFCs, financial incentives for energy efficient installations and minimum energy efficiency requirements. But we've seen that the bans on HFC was a bit more important, or seen as a bit more important by the respondents than the other factors. So this also shows policy, and especially the bans on HFCs, is an important driver of the uptake of low charge ammonia systems. So now, before I move on to the next chapter, we are going to do a short poll.
Thanks so much, Zita. Yeah, before we get to the part that everyone really wants to hear about, the market trends, let's do a quick poll and see. I see more people are joining us. So yeah, the first question, do you currently work with ammonia systems? You'll see your options there, yes or not at all, or you used to before, or you plan to do so in future. So let's give you a few seconds. Oh, it's very exciting. It seems like a lot of the people joining us are working with ammonia. Let's give it a few more seconds to give everyone time to vote. It's looking very promising so far. Okay, it's the final 5 seconds. Just make sure you take part. Okay, everyone ready? Everyone cast their vote? Okay, let's see. I'm gonna end. Let me share the results with you. It looks like about 80% of everyone currently works with ammonia, 3 don't, and the 1 person plans to in future. So this is very promising. I'm glad people are working with low-charge ammonia. Let's see, I think we've got another one. We're gonna help us there, that office. And see, okay, you guys ready? Now that you've figured out how to do it, should be easy this time. Hope you've been paying attention. What is the proposed definition of low-charge ammonia? It should be less than which one? Your options are 5 pounds per ton of refrigeration, 10 pounds, 15, or 20. This one's a bit more tricky than the previous one, so hope you've been paying attention. For those who've joined us late, you'll get the next questions, don't worry. Let's see, I'll give you 10 more seconds because I think you guys are struggling a bit more with these ones. Can you see? Okay, is everyone ready? I'm gonna end the poll. This is your last chance, eh? Okay, let's see. Well, the good news is the majority of people got it right. The right answer is 10 pounds per ton of refrigeration. But as there's no set definition, there's actually no wrong answers here. Thank you for sharing this. Just a quick note as well, a reminder to send us your Q&A questions so we can answer them. I'm sure you'll have a lot more to say after Zita's next slides. But Thank you. Back to you, Zita. Are you ready to share the market trends, the interesting stuff we found?
Okay, so thank you, Ilana. Going back to low-charge ammonia today. So yeah, this is chapter 5 of our guide. And we have done, first of all, we have done a data collection with system manufacturers of low-charge ammonia systems all over the world. And we have done this in 2019. And so here you can see the results. You can see that there is that there are clear hotspots in the US and Europe and Japan. So there are approximately 530 installations in the United States, 2,200 in Europe, and 870 in Japan. And so this is about all different kinds of ammonia systems, for example, DX systems, package systems, different kinds of chillers, indirect systems, cascade systems. And we are also giving a short technical description of these in the guide. So just to give an introduction. Then this data collection. So in total, we have more than 4,000 installations globally. And it's very interesting to see that, yeah, there are these clear hotspots in Europe, North America, and Japan. So as I've already mentioned, in the US, it's the regulations that drive the uptake of low-charge ammonia systems. And in Europe, it's more about safety standards and efficiency requirements. And in Japan, similar to the US policy and the subsidy program that is driving the uptake of low-charge ammonia systems. Then we come to a survey that Shecco did in the first half of 2019 with more than 300 industry experts. And they came from different branches, like they were manufacturers, contractors, consultants, end users. And the focus was on the extent to which low-charge ammonia is used in businesses and the drivers and barriers for adoption. And I'm going to present you the most interesting results of that. So first of all, the questions were asked to the different types of respondents. And here we have a question that was asked to equipment manufacturers and component manufacturers that already work with low-charge ammonia at the moment. And the question was, what percentage of products will be used for low-charge ammonia in 2019? And we can see that the overall share is relatively low. So about 1/3 estimates the share to be between 1% and 5%, and 1/3 estimates it to be between 6% and 10%. But it's also interesting to see that there are approximately 20% who estimate this share to be at more than 50% already. And overall, there's a huge potential to scale up the use of low-charge ammonia in businesses. Then we have another interesting question, which is about a premium. So all the respondents were asked, would you or your customers pay a premium to reduce the ammonia charge? And here we can see that, 1/3 each would be willing to pay up to 5% on capital costs compared to a traditional ammonia system, or up to 10%. So in total, more than 75% are willing to pay a premium, and only around 25% are not willing. So this is an indication that the capital costs are not as important as the overall costs, which include the maintenance and operating costs. And this is also supported by the next result, where all end users that do not have any low-charge ammonia installations at the moment were asked which factor they would consider most for their future purchases. And all factors here had to be ranked from 1 to 5. So from 1 being the least important and 5 the most important. And all the answers were ranked as similarly important. So they are lower total life cycle cost, total cost of ownership compared to competing technologies, lower capital costs than competing technologies, factory tested systems, meaning a smoother startup process, faster installation time compared to competing technologies, opportunity to customize standard products to suit my business needs, incentives to reduce capital cost of equipment, and shorter lead times compared to competing technologies. And so the most important was slightly in front of the others, a lower total life cycle and cost, which was a bit more important than the lower capital cost. Then in chapter 5, we also have case studies by our partners, Scantec Refrigeration, Vaterus and Alfa Laval. And so there's a case study about the centralized low-charge ammonia system by Scantec, a plate and shell heat exchanger by Vaterus, and a semi-welded plate heat exchanger by Alfa Laval. And in these case studies, the system design is described, the application, and also how the charge of ammonia was reduced. Then we will move on to chapter 6, the future. So talking about the future potential of low-charge ammonia. And first of all, we included an exclusive interview with Evapco, with Kurt Liebendorfer, Vice President at Evapco. I'm not going to present the whole interview, of course, now, but only two important quotes from it. So he's talking about the efficiency and the safety aspect of low-charge ammonia, saying that ammonia is the most effective and efficient refrigerant out there, and that low-charge ammonia technology allows it to be applied easier and safer. So again, we have the safety standards that we talked about before. And then he also gives an insight into possible future applications of low-charge ammonia. So low-charge ammonia can also further penetrate the supermarket and light commercial markets because it will become more competitive with commercial grade equipment, along with already being more energy efficient. So these are two quotes that we thought are very interesting and important, and you can read the full interview at the beginning of chapter 6 of our guide. Then we will continue with our survey. So talking about future projects, low-charge ammonia is often considered for future projects. And here we have questions for manufacturers and contractors that do not work with low-charge ammonia yet at the moment. And almost half of them plan to start working with low-charge ammonia, which is very positive and very interesting result. Then the same questions for end users. So all end users were asked which technology they would consider for future projects, and multiple answers were possible. And most of them, so 50% each, chose low-charge packaged ammonia systems and optimized centralized ammonia systems, which shows the high interest in low-charge ammonia. And it's also interesting to note that the HFC-based systems were not that popular with the respondents anymore. Then we are talking about the future market share. So the respondents were asked how they estimate the market share of low-charge ammonia installations in industrial refrigeration to be today in 2019 and in 5 years in 2024. And we can see that overall this estimate is growing. So in 2019, there was still half of the respondents that said that the share of low-charge ammonia in industrial refrigeration is 0 to 5%. And in 2024, this number decreased, so only 11% would say that. And then the majority of respondents estimates the share to be between 6 and 20%. And 24% of them even estimate this share of low-charge ammonia in industrial refrigeration to be higher, to be up to 50%. So this is an overall growth of this estimate. Of course, this does not reflect the actual share of low-charge ammonia in the market, but it's good to see what the respondents think and how they perceive it. Then this growth is, especially is expected in some key regions, which are North America and Europe. So seeing from the other survey results that we had is not surprising. North America had 41% of the respondents and Europe 37%. So these are the most important findings of the survey related to future market share. And then we will come to the conclusion. So low-charge ammonia offers a solution in regards of safety concerns and policy restrictions of traditional or conventional ammonia systems. And so we said that it's propelling this old technology into the 21st century because ammonia has been used already for 150 years and now it offers new possibilities. So first of all, low-charge ammonia makes it possible to extend ammonia's use in industrial refrigeration where it is already being used. And it opens up the possibility for new applications, which are supermarkets and air conditioning. And with our data collection, with system manufacturers and a survey that we did online, it was found that there's an increasing number of low-charge ammonia installations worldwide, and that the key regions are Europe and North America. So, and before we move on to Q&A, we are going to do a short poll again.
Well, before we do the quick poll, just a reminder that we will be sending you the presentation afterwards, and you can download the guide. It'll go live as soon as we're done here. Everything is ready for you. So, but then we'll send you the link as well, but also keep an eye on social media for if you want it quicker. So you want to go to the next slide, Zita? And then, yeah, before we get to questions, which I remind you, please, you've got that little Q&A button there. Just to give you a bit more time, we're going to do another quick few polls. The first poll, which region currently has the most low-charge ammonia systems? Once again, I hope you are paying attention. The options are America, Europe, Australia, or China. So it's quite a, I would say it's tricky, but I suppose it could be logical as well, seeing as a lot of you work with ammonia already. Okay, we're going to give you a bit more time. Okay, give you 5 more seconds. It seems like a lot of you have voted already. Well, let's see what the results are. Let me share with you as well. So yeah, the overarching majority said Europe, which was right, as Zita presented. Yeah, a few said America, but yeah, not a lot of you had any hope in Australia and China, but hopefully they'll come catch up soon. Okay, let's do one more poll. It seems like people are getting the hang of this now. And do one last one. Okay, which of the following do you consider the greatest barrier to the uptake of low-charge ammonia? We've now seen what Zita presented on what other people think, but for you, what is the biggest challenge? The equipment costs, the lack of skilled technicians, lack of industry knowledge, or perceived dangers and safety concerns? Yeah, it's a bit tricky because you can only have one vote, and I'm sure all of these are an issue, but let's see which one bothers you the most. Okay, we're going to give you 10 more seconds just to make sure we've given everyone enough chance. I see we've got a question already coming through on Q&A. Reminder to everyone else to also send yours through. Okay, on that note, let's end the poll. Okay, it's quite split. It's seen 41% of your equipment costs. That is a bit of a challenge. Actually, on that note, we must watch the space for cooling as a service. It might kind of solve all that problems. Lack of skilled technicians, 15%. Lack of industry knowledge on 24%. And perceived dangers and safety concerns on 21%. Awesome. Thank you everyone for taking care in the poll. Well, taking part of the poll. We're going to now go to Zita, who's going to answer a few questions for us. Are you ready, Zita? Just have to turn your mic.
Thank you, Ilana. So I saw that there are 2 questions. The first one is, are you planning to come up with a guide on how to repair low-charge ammonia in the future? So unfortunately, I have to tell you that we are not planning this because we are doing market research and technology research. And so we do not give any practical instructions. So we do not give any instructions on repairing, on how to handle the systems. This is not our business. So we are doing market research and technology research. We give an overview of what's happening around the world and also technological insights, but it's not these practical instructions. I hope this has answered your question. And then the next question is what proven technologies are available to reduce the ammonia charge? For example, DX ammonia systems improvements. So in the guide, we are presenting different kinds of low charge ammonia systems. One of them is DX system. And then we also describe how the DX system works and how it's possible to reduce the charge with it, for example, with improved evaporator design. Then we also present other types of low-charge ammonia systems, which are packaged systems or distributed systems, indirect systems, cascade systems. So we are presenting all these compared to a traditional pumped recirculated system. So there's a short technical description and very simplified sketches, but just to show what is possible and what is being done at the moment. I hope that this answers the question.
Yeah, you can actually go take a look in the guide. There's, as Zita said, there's a good description on all of these and some technologies on how to actually reduce the charge. Because I see there's another question in the chat for innovative technologies for reducing the charge, not just for DX. And you can actually have a look at a guide, and we don't just have descriptions of it. There's also actual applications from around the world where people have done this. So it's not just a hypothetical or this would be nice to have. There's actual concrete examples of completely mix of applications and the different methods people took to reduce the charge, and it actually specifies the charge as well. So it's a good example. Thank you, Manuel, for your comment. Yes. No, I just wanted to address Manuel's. Thank you very much for the good information. I appreciate it. And then Zita, you're going to address the last question?
Yeah, there's one question. What is low charge technology doing in order to retrofit actual systems? So I must tell you that we did not include the retrofit in the guide. So we can come back to you later with your question and to your question in writing, but it's not the subject of the guide. So yeah.
On that note, Zita, I see in the chat there's another question about how many pounds do you consider the low charge ammonia system? Do you just want to give us that number again?
Yes. So the point is that there's no definition in the industry of what is low charge ammonia at the moment. And so we are just presenting what is the viewpoint on the industry of that. And there are different definitions that have been proposed by industry stakeholders in the US mostly. And they are, so for example, the International Institute of Ammonia Refrigeration proposed between 0.5 pounds per ton of refrigeration, which is 0.065 kilogram per kilowatt, to 7 pounds per ton of refrigeration, which is 0.91 kilogram per kilowatt for the Europeans. And yeah, so in overall also with other industry associations, we can see that there's a threshold of 10 pounds per ton of refrigeration that is being proposed, but there is no real fixed definition in no country or region, neither in the US, and neither in Europe or in Japan or other regions of the world.
I see we just got another question about the loosening of ammonia restriction laws. I think, in fact, they're actually tightening a bit, and that's why in countries like Japan, it was previously very difficult to have ammonia systems. But now, because of low-charge ammonia, they're no longer such a big risk and not such a high safety risk, so people can actually now put in ammonia systems who previously couldn't. So policy isn't such a big barrier anymore. Zita, would you want to elaborate on that?
No, I think this is also something that we had in our conclusion, that low-charge ammonia can be a solution or an answer to policy or safety restrictions that were previously there for higher charges, and that with lower charges, this can be solved. So this is a good way to use ammonia, which is a very efficient and environmentally friendly refrigerant, to use it in these applications where it could not be used before.
Okay, are there any more questions from everyone? If not, thank you, Zita, for the great presentation, and actually a lot of hard work that went into this guide. I think it really is something to be proud of, and hopefully, as we said, it will help propel ammonia into the 21st century. It has been around for a very long time, and because of safety risks, people haven't really been considering it. And even though it might not always be the answer, it would be nice if people actually can look at it as an option at least. So as mentioned, we will send you the presentation afterwards, and the webinar has been recorded and it will be available. But we invite you to download the guide. It's free, share it with everyone, have a more in-depth look. And if you have more questions when you've gone through it, please, there's contact details on there as well. Get in touch with us. We'd love to hear from you and what you think. Also, I hope it adds value. And we will be launching a CO2 guide as well next year, so keep an eye out on that. In the end, Thank you everyone for joining, and thank you for your time. Have a good day. Zita?
Thank you very much. Goodbye.
Thanks everyone. Goodbye.